Welcome to the 27th Oracle Virtual Summit. Well, we started the series in September 2020, and now it's 26 sessions later, we have the last session of Season 3. We had more than 50 speakers, and we had close to 3,000 participants, and that we're still overwhelmed by that reaction. I think that's really a big success, and we really like that. So usually the feedback when you do a performance or when you do a presentation is applause at the end. But of course, this is a little bit tricky with the Zoom session. So we need to use Zoom statistics for that. And I think there's only one very good value that shows the quality of the speakers, not of the host, of the speakers. It is how long in average people stay in the room, stay in the session. And what we see in our statistics that over all presentations, the answer is that people stayed more or less 100% in a session. So everybody joined early, stayed until the end. So that is a very good signal. And I think I'd like to take the opportunity here to thank you, all the participants for being there, and all of our speakers for delivering the great content. So that's very nice. And we really appreciate that. Okay, so let's go to the next one. And what should I say? It's a real pleasure for me to have Ashish Ray again in the Virtual Cloud System Summit. Ashish supported us with the first session, and that helped a lot to get the, let's say, kickoff attention for our series. Last time he spoke about X8M, and today is the focus on X9M. So welcome back, Ashish.
Thank you, Ralph. It's always my pleasure to talk to you, Bozana, and the Oracle in Germany, and the rest of all the German customers who have provided us with excellent feedback over the last several years.
Okay, thank you. Actually, before we start, maybe you introduce yourself for our guests, for the one you probably don't know what you're doing.
Absolutely, Ralph. So my team leads product management for all aspects of Exadata, including on-premises, cloud at customer, and cloud services, and also related technologies such as zero data loss recovery appliance, and a lot of the core Oracle database features and maximum availability architecture.
Okay. Yeah, we heard about that, right? Yeah. And your title, Vice President of Product Management, it really shows that you're driving that here. Okay, so before we start the show, let's have a short look on the upcoming events. So as I said, this series here with Virtual Cloud Systems Summit will have a small pause. We will come back, I hope, with hybrid or even on-premise. We don't know of how that works out with Corona, but that is the plan for the time being. We hear directly from Oracle product leaders and engineers about the features and best practices of Oracle IT infrastructure. We do that in the Oracle engineered forums, and you see the URL here, and you will get all the material, of course. You get the PDF version here, and you can easily find where all that is. To register, select the webinar you're interested in and just register for it, and it will just appear. So easy doing. Okay, from here, I think we should not waste any time. Ashish, the stage is yours. Looking forward to your background on the engineering part.
Thank you, Ralph. So I hope with this session we can have an interactive dialogue with regards to how we look at Exadata from a product development standpoint, how we look at Exadata Cloud at Customer, and also Zero Data Loss Recovery Appliance, and specifically what we have done with regards to the latest platform, which is X9M. Mm-hmm. And as you know, our vision of Exadata is around providing our enterprise customers with an ideal database hardware. By that, we mean an optimized infrastructure around scale-out database, optimized compute, networking, and storage. We do deep engineering at every level of this infrastructure. So that includes, obviously, the hardware, but also what we label as a system software. And when I say deep engineering, these are database-centric algorithms that vastly improve OLTP analytics, consolidation, and mixed workloads. Mm-hmm. And of course, we make sure that this entire infrastructure, software and hardware combined, are available to you with complete automated management And this could be deployed on premises. And as I mentioned, in our public cloud, OCI, Oracle Cloud Infrastructure regions, and also in a form factor that we call Cloud at Customer. Exadata pretty much has been now it is kind of like the de facto standard of deploying Oracle databases. We wish we could include more logos in here. We just ran out of space in this slide. But we did a fun exercise. We looked back and said, okay, out of the Fortune Global 100 companies, how many companies run Exadata? And we came up with a list of 87. Wow. And the remaining 13 are presumably our competition. So they probably don't run Exadata.
They're hard to convince.
Yes. And with Exadata Cloud, 45 of them run some variations of Exadata Cloud. So it has been absolute fantastic penetration over the last several years.
Cool.
Let's look into the platform. With that introduction, let's look into some of the deep dive inside the platform, specifically with regards to some of the X9M capabilities. So as I mentioned, Exadata by itself is an extreme performance scale-out database platform. With regards to what we have done for X9M, let's start off with the database servers. What I'm showing you in the schematic is a typical full rack, but these days most customers use Exadata as a starter rack, and then they elastically expand. Elastically expand means they can expand using database servers or storage servers, depending on their workload needs. So for X9M, for the database servers, we have taken the latest 32-core Intel Xeon processors called Ice Lake processors. So that's an improvement. That's a 33% improvement from the previous X8M generation, which used to be 24-core processors. Then we have also expanded or made the memory expansion more flexible. In X8M, it is up to 1.5 terabytes per database server. We have improved that again by 33% to 2 terabytes. And we also continue to have the 8-socket database server available for more of a scale-up SMP kind of a workload. So those are the improvements in the database server. For the network, we continue with the 100 gig RDMA over converged Ethernet internal fabric. So that is one of the reasons we have been able to get phenomenal latencies, very low latencies throughout the stack using this extremely fast, low latency, high bandwidth network. With regards to the storage servers, we continue to offer high capacity storage, extreme flash storage, and extended storage. But here also we have made some improvements. We continue with the 16-core Intel Ice Lake CPUs. The persistent memory remains at 1.5 terabyte persistent memory, but we are using the latest generation persistent memory from Intel. And that's another reason later on in the slide, I will talk about the incremental performance, which is a fantastic incremental performance numbers for X9M. And we will also talk about how, from a drive capacity standpoint, we have improved from what used to be 14 terabyte drives to 18 terabyte drives. When we look at this entire full rack, this whole notion of full rack, obviously you can have the traditional full rack notion, but you can also fill it up with database servers or fill it up with storage servers, depending on your workload needs. So for example, in one single rack, you can have up to 19 database servers. And if you look at the 19 database servers, really we are supporting in one 42U rack, more than 1,200 database cores with 38 terabytes of memory, which is phenomenal. Yeah. And similarly, if you fill it up with storage servers, we can support up to almost 4 petabytes of raw drives, along with more than 500 storage co-processing cores. So all these numbers are phenomenal. And what we have done with X9M is a continuation of what we have always done, how we have made this journey since the inception of Exadata back in 2008. And if you look at some of the numbers that are presented, especially in the last two columns, that kind of pinpoints what our engineering organization has been able to achieve purely from a database optimization standpoint. And that way, I think Exadata is absolutely unique within the industry, especially for enterprises, that over the last 12, 13 years, how we have been able to consistently provide a superior architecture from an infrastructure standpoint, from a software standpoint, that continues to deliver absolutely exceptional, outstanding results with regards to database workloads.
Yeah, that's right. Ashish, now we announced the second generation of the Ethernet-based X8 and X9 system with Ethernet components, and
yes.
These components can be mixed. If a customer, for example, wants to upgrade a system, you can use the newest version. Is that planned to be, let's say, a feature that will be continued in the next releases of the machine?
Yes, absolutely. So because now Rocky, that is the 100 gig Rocky network that kind of is the common fabric between X8M and X9M, you should be able to mix and match components. So suppose you have started off with an X8M rack, and now you want to expand with expand database servers or storage servers. Yeah, you can bring in X8M storage servers or database servers, and similarly, you can also bring in X9M database servers or storage servers.
Okay, that's cool. I have another one on the development of the machine. So, what is the typical development cycle of an Exadata? Are you doing one generation and then you publish it, or are you working parallel on several releases of the machine? How is that happening?
We always work in parallel on multiple releases, and the reason, and Ralph, that's actually a very interesting question. The reason is in the IT industry, the computing industry, the pace of innovation has been absolutely phenomenal. And the innovation does not stop, right? So if we are started on a release path, so for example, if you're starting on an X9M path or X10M or X11 and so on and so forth, we have a very focused goal with regards to like what can be the infrastructure target for that particular release. But at the same time, there may be very interesting technologies out there in the horizon that we have to bring into our labs and that we have to evaluate with an eye towards future releases. And that's the only way, Ralph, we have been able to, this looking into the future, and that's kind of the way we have been able to deliver these exceptional platforms over the last 12 plus years.
Okay. So we're using a lot of Intel technology. Intel is a very strong partner of us. So you probably know more into the future of Intel products than an average guy in the market does, right?
No. I would not claim that, but again, the progress and the development, the pace of development has been fascinating.
Yeah.
Okay, thanks, Ralph. Those are very excellent questions. And feel free to stop me anytime, Ralph, if you see interesting questions come up.
Yeah.
And I love doing this rather than going through the slide sequence. This kind of dialogue and interaction always helps, and it's much more engaging. Thank you. So we talked about the platform, and then let's look into the workloads. I kind of alluded to the workloads. But before we go into the workloads, let's take a step back. And for you Exadata practitioners, this should be common knowledge. But in case there are other customers who are coming in, this whole notion of Exadata and getting intrigued by it, the principal reason, one of the principal reasons we have been able to do this, besides the database optimized hardware, is what's happening in the software. And this is what maybe you have heard, this whole notion of Exadata secret sauce. And this whole concept of pushing database processing from the compute layer to the storage layer. And that's where all the smartness happens. So that means deep in the storage infrastructure layer, we can take advantage of like Oracle block formats and protocols. And once that intelligence is there, and once that is enabled by an extremely high bandwidth, low latency network that we refer to as internal Rocky network, we can achieve wonders. And that's kind of the net of Exadata. We push database I/O processing with a whole bunch of intelligent software components in the storage layer so that it is the performance-wise, it is phenomenal. And then we can also scale it out without any bottlenecks. And that goes towards the massively parallel architecture of Exadata. So with that said, in one of my initial slides, I kind of alluded to kind of the workloads that we target. Of course, we start off with OLTP, analytics, and consolidation, but you have to keep in mind with regards to Exadata, because of the power the infrastructure provides, the workloads can be absolutely mixed. So it can be an in-memory workload along with some OLTP, and then you put in some other databases also with regards to making Exadata a very highly consolidated platform, reducing your data center space. So all of this is available with Exadata. And of course, the idea being what you're running on Exadata is this whole notion of converged Oracle database. That is, you're not creating individual databases for individual workloads. It's once like single Oracle database, either through multiple PDBs or CDBs. But essentially, your applications don't need to change. And you are targeting workloads, as I mentioned, in memory, or it could be graph, it could be spatial, it could be JSON, and targeting for profiles such as OLTP analytics or consolidation. From an infrastructure standpoint, the way we enable the very high OLTP workload support is through the scale-out storage. I kind of mentioned that. And I will also talk about these notions of RDMA, persistent memory, and flash. But this massively parallel scale out along with the software optimization and making sure there are no bottlenecks. And in case there are any individual hardware components that may be failing or that might have failed, the software transparently takes care of redirecting IO traffic or redirecting processing such that there is no application impact. Mm-hmm. So those are the technical capabilities which enable very high OLTP workload support. With regards to analytics, that's where a lot of our secret sauce comes in. Unique smart scan, massive parallel processing at the storage layer, along with technologies such as smart flash cache and storage index. And then, of course, unique columnarization, not only in the memory layer, but also in the flash layer that supports IO vector processing, working in conjunction with the processors and the chips. Those are some of the capabilities which enable very high analytics workload support. And then you can bring all of this together with the power of the underlying infrastructure, enabling the best consolidation. And to do that, we have enabled unique prioritization of traffic. And some of these are transparent to the users, and some of them you can create policies such that you can create prioritization across processing, that is the CPU, across IO, across network, so on and so forth. And then you can also create isolation boundaries, whether using PDBs or VMs, such that the workload characteristics of one particular application does not impact the other applications. Mm-hmm. Looking into slightly deeper into the OLTP, the next 3 slides, I will spend probably a couple of minutes each on how we have enabled these very high workload characteristics. Really kicking off with X9M and this idea of this technology called RDMA, remote direct memory access, over 100 gig Rocky network. That means that we have enabled extremely low latency. What used to be hundreds of microseconds, now we have enabled SQL access less than 20 microseconds. And that's how we have enabled very fast OLTP traffic. And doesn't matter whether it's high volume because you can completely scale out. So that's what enables this very fast OLTP workload characteristics. And I also talked about how in the typically in Exadata, we have eliminated all bottlenecks. So for example, if you're looking at RAC, real application cluster traffic between, say, 2 nodes, we have introspected deep inside the protocol and enabled things like technologies such as direct-to-wire protocol or smart fusion block transfer, such that, again, using technologies such as RDMA, you can, in these optimized IO traffic, you can eliminate all of these bottlenecks. And these incremental work that we continue to do at the deep engineering level, all of these incremental works, they add up. And they add up to enable all of this high volume, low latency OLTP workloads. Similarly, I also talked about how we have high availability technologies that can instantly detect and handle failed or failing components, enabling automatic recovery at the software level without any application impact. So those are the technologies technical capabilities which enable very high OLTP. Similarly, for analytics is about parallelism at the storage layer. So that's what some customers have referred to Exadata as the massively parallel platform. So you can run all of these, say, analytics workload. Maybe you're running queries over a table or a set of tables which is across, say, 10 million rows. So you can run it without any bottlenecks and freeing up the database CPUs, but running them at the storage layer. And there are the technologies such as tiered flash cache, storage indexes, hybrid columnar compression, in-memory columnar compression. All of these enable very fast analytics support in the Exadata platform. These technologies that I'm mentioning, these are not new per se in X9M. These are all software advancements that we have made over the last several years. So they apply to previous generations also. Mm-hmm. But then what happens is as the platforms become stronger, some of the software capabilities become even richer. And that's why we are able to publish even faster analytics rate with each successive Exadata generation. And then quickly summing up the whole consolidation aspect, at the initial slide, I talked about prioritization. So you can do prioritization of latency sensitive operations. You can do prioritization of user-directed workloads. And you can then also create isolation between tenants. And this you can do either through VMs or through PDBs. Thereby what happens in a single Exadata rack could support multiple workloads, multiple Oracle databases, thereby freeing up data center power space, cooling. And maybe this is a way, if you're looking at decommissioning some data centers to embrace a cloud strategy, this could be a very effective way to embark on a cloud strategy, getting rid of physical data center space. What also happens is the underlying benefit of consolidation is cost effectiveness. We all claim, or we are proving that Exadata can support, from a performance standpoint, phenomenal numbers. This, from a business standpoint, means that in a set of time, maybe say in 5 minutes or 15 minutes, now you can do more, which means overall you're becoming much more productive. And by doing more with less, that means you are saving on your system resources, you're saving on your human resources, and you're saving on your overall system management, leaving aside the data center power space and cooling. And this we refer to as Exadata economies of scale, which is why many of our customers have told us after embracing Exadata, they have seen phenomenal cost advantages within the enterprise.
Yeah.
So what about X9M? I went through a journey of how, from a technology standpoint, we are providing support for these various workload characteristics. With X9M comparing to X8M, and mind you, we had released X8M less than 2 years back. So in a matter of 2 years, without any change in price, and that goes back to the cost effectiveness that I talked about, unparalleled price performance. Specifically looking at OLTP, now what used to be approximately 16 million IOPS in X8M, now we can support the same workload with 27.6 million read IOPS, 70% more OLTP IOPS support in X9M compared to X8M, again, without any change in price. One of the ways we are able to do that is we have embraced PCI 4.0 from a network standpoint, and that is supported not only by the underlying network, the network card, but also by components such as NVMe flash. So with that, along with the software optimization, this phenomenal increase, 70% more read IOPS support in X9M. And I kind of touched upon that we have improved the OLTP, improved the database processing also. What used to be 24 cores now is 32 core Intel Ice Lake CPUs. All of these have combined to this OLTP IOPS improvement. And IO latency remains less than 19 microseconds. What about analytics? How much have we improved in analytics? In analytics, we are very proud from a core engineering standpoint to break the 1 terabyte per second barrier. Again, software optimization, very powerful hardware components, the end-to-end integration at the deep protocol level, and using some latest technologies such as PCI 4.0 flash. So what used to be in X9M, the equivalent numbers was around like 560 gigabytes per second. We have improved that almost 100% with 1 terabyte per second. From an analytics standpoint, the increased database cores also help. The PCI 4.0 flash enables very fast network throughput. And this whole notion of how you can extend in-memory columnar processing from the in-memory layer at the database servers to the storage layer in flash, that also continues to contribute and gets even better from an algorithm standpoint to enable this very high analytics rate. From a consolidation standpoint, as you look into bringing more and more workloads in a single frame of Exadata, I mentioned the fact that 18 terabyte drives now replace 14 terabytes, with giving you 28% more storage capacity, higher memory per database servers. And in the database servers now, all local drives are now all flash. So we have moved on from disk and make them like SSD drives. So that will enable even further VM consolidation, and very high performance VM support will be enabled by that. So this slide in a nutshell kind of summarizes the fantastic performance improvements we have achieved with X9M, again, holding the prices steady. Yeah. And by the way, Ralph, one of the reasons we are able to hold the prices steady is when we, from an engineering level, when we source these hardware components, here I present to you a lot of hardware components. Yeah. Back in our mind, we have to make sure that we are choosing the hardware component that gives the best performance without increasing the cost. So a lot of thought process goes in making sure that from an engineer system standpoint, we are choosing the right infrastructure components.
Yeah, that's right. What we always forget is that we don't have to change anything to the application and to the database, right? So yes, you can just use this and enjoy the performance speed and all that stuff, and let's say being safe for noisy neighbors and so on, all the features we have when you run and operate multiple databases without doing changes to the code. I think that is very nice. You have no lock-in at the end, right?
Yeah, absolutely. Very good observations, Ralph. Yeah, one customer, they told me that, they have been using Exadata for several years. And they summarized it quite nicely. They told me that it's almost like bringing the Moore's law advantages to the customers themselves. And whether that's in the data center and cloud really doesn't matter, so that they don't have to figure out that are they getting the latest hardware or platform improvements for their workloads.
Yeah. That's a good aspect. You don't have to do it on your own at the end, right?
Yes. And of course, here, this goes back to the massively parallel layout that we have. Performance scales as more racks are added. This is the numbers that I present here, 1 terabyte per second or 27.6 million read IOPS. These are single frame Exadatas. Of course, if you attach Exadatas together in a scale out manner, you get even better performance. Yeah. I keep mentioning these technologies, RDMA, Rocky, and PMM. Let's spend a couple of minutes, 2 to 3 minutes, taking a deeper look into these technologies. We are very proud of the way we have engineered these technologies in an Exadata platform. So Rocky Remote Direct Memory Access is a way where you can access data. Like one computer is accessing data from another computer. So typically, if you would want to access data from another computer, you have to open up a network connection between the two. And you have to go through the standard TCP/IP process, and which is like, okay, connect and open the connection. And then from in the computer science terminology, this means that you have to issue the request, and that comes in as an interrupt. And then the CPU or the receiving end has to do a context switch. They have to do some IO processing, and they serve the IO back to the server, to the client, that is. And then the client is interrupted, and then the client has to do like, okay, now I am receiving some bits. So there is a lot of what we call driver processing goes on. What RDMA does is, both from a software standpoint and the network card standpoint, it reaches out for data access as if the distant computer, the remote computer, is like almost connected on the memory bus. So it's almost like doing a mem read, but along the network. That means you can totally bypass all the CPU context switches or any of the software interrupts. And that enables extremely high levels of performance from a low latency standpoint.
Sure.
So that's number one. And then number two is this notion of persistent memory that we have integrated starting with X8M, and we continue to improve working with our partner Intel in X9M. Is this layer between memory and flash. So giving you much higher performance than flash, although at less cost than main memory. And two things happen with this almost memory-like performance in this layer. This will survive any instance failure, in the sense that if you want to shut down, the bits will still be there. So normally, for example, if you are working on your laptop and if the laptop suddenly shuts down, you lose some work. That's not the case here. Any bits that are in persistent memory, because of the underlying physics, they will continue to be saved in that layer. And so we have integrated RDMA, we have integrated persistent memory, but that's not it. We have to make changes inside the database server processors, inside the database kernel logic, such that, for example, if you are writing database IO blocks in the persistent memory layer, and suppose now that there is a power failure and then the server boots up, the blocks are still there, but we have to make sure that you're writing blocks in a very consistent manner, because underlying the Oracle transaction semantics still are valid. That is, the transaction processing should be able to go on without any corruptions, without any other block check failures. So we had to do deep engineering at the database processing also to enable all of these technologies. So from an Exadata standpoint, what does that mean? In an Exadata, we have implemented this technologies at the storage layer. So that means now, if you think about it from a consolidation standpoint, if you're bringing in more and more consolidated workloads in a single or in an Exadata infrastructure, because these layers, these technologies are in the storage layer, all of these workloads automatically get the advantages or the benefits of shared storage. So that's number one. And number two, no application changes are necessary. No system changes, no configuration changes are necessary. All of these technologies work transparently. And that goes to your point, Ralph, that when you bring in these technologies, you don't have to make any big changes at your end. So here is a typical way of a non-RDMA way. Suppose if we had put this persistent memory layer, it's very fast. Suppose we have put this persistent memory layer in Exadata, but without using RDMA. That means we still have to do these context switches. We still have to do the CPU interrupts. That means we are potentially looking at maybe hundreds of microseconds, maybe 100 microsecond of IO latency. Now with RDMA, the way it changes is you're making direct memory mapped access, which means it bypasses, as I mentioned, bypasses network and IO software interrupts and context switches, right? And so with that, what used to be 100 microsecond, now that can be reduced to less than 19 microsecond. That's kind of like the secret sauce that's enabling this extremely powerful performance numbers with X8M and X9M.
Wow.
And because we enable it at the storage layer, we do automatic tiering between persistent memory, flash, and hard drives without any application changes or without any database or systems administration changes. And of course, you can extend this tiering from a high availability standpoint and also from a clustering standpoint.
Okay.
So these are like very fascinating technologies that we are using, and that way, the way we have making database optimization synchronous with some of these technologies is absolutely unique in the industry.
Yeah, that's really cool. So you're adding a lot of innovation there. So are there innovations that are considered by your team and they never make it into the product? Is that happening as well?
What we have seen is when we are working with so many of these partners, from a infrastructure standpoint, when we are ready, they also have to be ready, and vice versa.
Mm-hmm.
So if we have a target release in mind, so for example, X9M or X10M or X11M and so on and so forth, we may embrace certain innovations targeting for the release, and certain other innovative technologies may fall out for the next release, in the sense that maybe we find that the technology themselves are not ready, specifically with the database workload in mind. And that's what drives us, Ralph, that we have to make sure that we get the most optimized database performance without increasing costs.
Yeah.
And that's a very ongoing process.
Yeah. And that makes it easy because you have a really one target. It's a database. You're not, responsible for all workloads in the world, and you have to have the fastest web server. So we are talking here databases, and they need to be optimized. So that is very clear. Okay, so let's have a look into the software, right?
Yes. From a core R&D standpoint, our focus has always been on the software. We definitely have the hardware and the platform engineering group, but we have a very vibrant software engineering group also. And the whole idea of the software engineering is what you refer to, Ralph, is this whole notion of mix and match. In other words, investment protection. Mm-hmm. That means once you have the latest software capabilities, most of these capabilities should work for a previous generation of Exadata. And at the same time, this latest software is what enables this mix and match. So for example, if you embrace, say, Exadata Software 21.2, which is the latest release, you should be able to mix X9M components with X8M components. Mm-hmm. Our software development is in a very interesting stage now, Ralph. What happens is, from a core feature standpoint, whether that is multi-tenant, whether that's VM, whether that's scale out, whether that's elastic expansion, snapshots, we have delivered most of the very high level requirements over the last several years. Now, what we are doing is, this is almost a new wave of software development within the Exadata engineering team, is because very powerful hardware components are coming in. This enables us to do very minute, granular engineering innovations at a very deep level, which would not be possible otherwise. And that could be related to CPUs, that could be related to network, that could be related to memory. And as I mentioned, each of these components, each of these innovations, they add up to numbers such as 1 terabyte per second of analytics scan. And then number two is, I kind of mentioned, the industry is moving at a very fast speed. So our software is also working in parallel, such that not only we are making these deep changes, but we are also embracing the other innovation that is happening in the rest of the industry. So the Rocky and persistent memory are examples. So the latest release of Exadata Software 21.2, it has many of these advancements, many of these capabilities. If the chance permits, maybe we can have a separate technical drill down session on the latest software capabilities. But one example that particularly comes to my mind is what we refer to as a smart scan fast decryption. What used to happen in prior generations of the software, and this is what you see on the right-hand side, is we would make an extra memory copy to do the decryption, which is necessary for encrypted data, which is necessary for smart scan on encrypted data, right? And we will make this decryption inside the memory layer, but that would be on using an extra memory IO. And maybe there are opportunities to prevent any memory bottlenecks. And the opportunities came up with the latest X9M generation when we looked at our flash, when we looked at memory, and when we looked at CPU. Now we are able to do the decryption without this extra copy directly inline using the latest hardware components and the latest hardware technologies inside the CPUs. So that's an example of how in the deep engineering level, in the deep hardware level, we made that change from an application standpoint. What we have found that enables with X9M more than twice the faster decryption rates for smart scans.
Wow.
So these are just examples of like the engineering innovation work that goes on deep inside our technologies.
Yeah, that's very interesting. So what do you think is the most important future trend for hardware and software? Is that artificial intelligence? Is that machine learning? So where are things going here?
Definitely, we see trends of AI and ML coming in every layer of IT processing across the hardware and software. And at least in my personal view, seeing how the landscape has changed over the last several years, technologies tend to are becoming more software centric.
Mm-hmm.
And then the challenge is how using these software centric technologies, you can present a layer from a customer or a user standpoint. You can consume this layer without making substantial changes or any changes in the application layer, and consume it either on premises or cloud. So that has been also kind of like our engineering guidance.
Mm-hmm. Okay, thank you.
Good question, Ralph. So talking about cloud, what about Exadata in the cloud? As I mentioned earlier, that of course you can continue to run Exadata on your on-premises, but we have also enabling this notion of hybrid cloud, where you can run Exadata in a cloud at customer manner or in public cloud, such as Exadata Cloud Service. And our latest numbers show that 45 of the Fortune 100 companies have embraced some variation of Exadata Cloud.
Mm-hmm.
Exadata Cloud Service, this essentially means we have Exadata shapes, various generations of Exadata shapes available in our OCI public region. Latest count is there are approximately 40 or 40 plus OCI regions around the world. And we have recently announced support for even a higher number of OCI regions around the world. So then you can start consuming your database processing as a service, but the underlying infrastructure is all maintained in Oracle Cloud. Of course, now there is no notion of data center, which means that all your enterprise workloads with a similar performance characteristics now can be migrated to cloud, with the assurance being the underlying infrastructure continues to be Exadata.
Mm-hmm.
And we have created a very sophisticated cloud layer that we refer to as cloud control plane, which enables things like adding CPUs and elastically expanding CPUs and storage. And all of this orchestration can be driven through APIs. So that's cloud service. Some of you or many of you may not necessarily be ready to migrate your workloads to a public cloud, maybe for data residency reasons, maybe for latency or application integration reasons, or maybe for security and control reasons. So in that case, what we do is we bring this whole Exadata cloud concept to your data center behind your firewall, such that you can deploy this Exadata cloud in your own data center. You continue to manage your own Oracle databases, while Oracle will monitor and manage the Exadata infrastructure. And this is extremely popular now. Many of our customers are seeing this as the most efficient cloud adoption strategy. For the first time, along with on-premises Exadata, we are also bringing in Exadata Cloud at Customer X9M. And this goes to the similar set of performance improvements that we have seen for on-premises Exadata. So for example, the 32-core Ice Lake processors and the 24-core Ice Lake processor in the database servers, in the storage layer and the server, they will enable similar performance numbers in X9M. The numbers that I have given here for X9M in XSCC, these shows the improvement corresponding to the X8M generation of XSCC. Similar improvements, like 87% more in IOPS, 80% more for analytics throughput. And all of this, again, with no change in price. That means that your Exadata price performance numbers continue to be phenomenal across on-premises and cloud at customer.
Okay.
Very quickly, for 2 minutes on what cloud at customer is. As I mentioned, that you continue to own your database schemas, your application logic, and you manage your databases yourself in the sense that you continue to maintain the ownership in the database layer. And this you're consuming through VMs. So which means Oracle owns everything from the hypervisor and beyond. So the hypervisor, the servers layer, whether these are the compute server, whether the storage servers, the fabric, all of these are managed and monitored by Oracle using cloud control plane software. So in your data center, you're just consuming your database as a service with the Exadata infrastructure. And we have very flexible commercial policies which enable you to do that. As I mentioned, we have this notion of cloud control plane, which enables very common lifecycle tasks that you access through a very user-friendly UI. You're logging into our cloud console, and you can do things like creating databases, creating backups, scaling up databases, scaling VM clusters, creating data guard associations. You can do through simple clicks using our cloud control plane or through APIs, REST APIs, which means on top of it, you can create Terraform work orchestration. For example, if you're looking at Exadata Cloud from a DevOps perspective.
Mm-hmm.
One very unique feature we have released for Exadata Cloud at customer is this capability called operator access control. I have mentioned that, okay, you are consuming your databases as a service on an Exadata infrastructure in a cloud at customer model, and Oracle is coming in and managing and monitoring the infrastructure, doing the infrastructure updates as and when required. But sometimes if you are in a regulated industry, for example, maybe certain financial services companies, you may want to audit when Oracle operators come in and say, for example, if something needs to be diagnosed at the infrastructure layer, the experts are coming in and doing some debugging, you may want to audit. And so operator access control enables you to do that. This incoming request by Oracle operators will not be possible unless you release the request, unless you enable the request. So that means customers, even though this is cloud, you control access to infrastructure to limit when operators have access, which components they can access, and the specific commands they can execute. So this is complete cloud reassurance. You are transitioning to a cloud strategy with, at the same time, keeping controls around it. And this is absolutely unique. No other company provides anything like this today.
Okay. So, Ashish, we talked about switching from an environment to an XRCC environment, clouded customer environment, as a good solution. So some of the customers already purchased Exadata, for example. So why should they consider to invest into XRCC?
Yeah, that's another question. And that's a trend we are seeing, Ralph. If you have invested on Exadata over the last several years, you're already familiar with what Exadata brings, performing the scalability, the reliability, the security. Now, at the same time, you may have a cloud strategy or you want to embark on a cloud strategy, but because of various other reasons, as I mentioned, application integration, latency requirements, control requirements, you cannot just take all your workloads and move to public cloud. So many of these customers are looking at Exadata Cloud at Customer as a very efficient transition to a cloud strategy with them keeping controls without any IT disruption. That's one trend we are seeing. And the second trend is, of course, the underlying trend is modernization. If you're looking at your overall digital transformation or digital modernization and looking at various ways, you start off in the data management layer. And Exadata Cloud at Customer enables this, the digital modernization at the data management layer without the disruption that normally you may have to entail if you were transitioning to a public cloud. So that has been one of the guidance, specifically in certain industries such as finance and telecom.
Okay. Okay. We already see zero data loss recovery appliance on the screen. So that is a powerful extension to Exadata. What do you think? Is that a combination that should always exist? So no Exadata without recovery appliance, or
Yes, a lot of our customers, when they are trusting Exadata for their business critical to mission critical workloads, which means Exadata now is supporting for them, it's supporting petabytes of worth of data. They really have to look at very smart, sophisticated, and cloud scale data protection. That would not necessarily be achieved by point solutions like our point backups. And that's where zero data loss recovery appliance comes in, using the Exadata infrastructure as a basis, but with sophisticated data protection software that is completely database optimized. Now you can, not only you are scaling your database processing, but you're also scaling data protection of those databases. Mm-hmm. And this combination is unique. Many of our customers that started off with Exadata as a journey, and they looked at data protection, they embraced recovery appliance. And for many of these customers, they are pretty much standardizing both on Exadata and also on recovery appliance. So it's an end-to-end data processing to data protection framework for these customers. Mm-hmm. We have made certain improvements, similar improvements for X9M generation for zero data loss recovery appliance, Ralph. As I mentioned, 18 terabyte drives replacing 14 terabyte drives. The same benefit comes in for recovery appliance. That means immediately you get 30% increase in your backup capacity. And that is phenomenal. Our full rack now of recovery appliance now supports more than 1 petabyte of physical capacity. And if you look into backup compression and the fact that you can do incremental forever, you're really looking at 13 petabytes of effective backups.
Yeah, that's the point, right? Yeah. You can store a lot more, right?
Yeah. Yes, absolutely. Very fast data restore rates and, of course, backup rates. Here we mentioned 24 terabytes an hour. I have to confess, one of our customers, after they have deployed recovery appliance, they came back with a number of 35 terabytes an hour. But that is not a number we ran. So we said, okay, from an Oracle collateral standpoint, let's stick with 24 terabytes, which is what we achieved. For recovery appliance, it is now very popular in the sense that customers are seeing recovery appliance as a very effective strategy to protect from ransomware. Before I go into the ransomware, I spend a couple of minutes on ransomware. The other thing that we did for the X9M generation, so similar to Exadata, there is a base system, and then you can expand your base system with elastic components in the storage layer. For the base system, we reduce the price 50%. We halved the price of base system. So that, along with a 30% increase in backup capacity, that means phenomenal price performance numbers for zero data loss recovery appliance. With regards to ransomware, how can you use recovery appliance to defend and recover from ransomware attacks? And we actually have a technical white paper on this. And the way this works is from the databases you're protecting, the databases, they need to be encrypted. And that's where Oracle database technology such as transparent data encryption comes in.
Yeah.
And recovery appliance provides protection on a real-time basis because you're sending not only the incremental backups, you're sending the redo blocks directly to the recovery appliance. So very fast data restore with zero data loss because you're sending the latest redo blocks, right? You're not doing only incremental backups. And the infrastructure itself is very hardened, ultra scalable, both from a compute and storage standpoint, because essentially it's the Exadata infrastructure, Exadata platform that's powering recovery appliance. You can replicate the backups to another whole separate layer of recovery appliances, and you can create what's called a cyber vault, and you can create your downstream recovery appliances there. And by air-gapped backups means this is only through a network connection, which is firewall protected, and that can be disabled anytime. Mm-hmm. without disrupting any of the backup data. From an administration standpoint, you have separation of duties. So for example, customers who are doing, or the groups of people who are doing the backups, they may be different from the database administrators. So we have created these very flexible policies. And we do end-to-end validation, monitoring, and compliance reporting. This entire architecture is very effectively deployed to prevent ransomware attacks in many of our enterprise customers. I totally encourage you to look at this. I will summarize now with the URLs where you can find some relevant technical collateral how to implement this.
Yeah, that's good. Cool.
So talking about summary, so Ralph, with you and the rest of the audience, we went through a journey. Starting about 2008, 12, 13 years back, we have seen how consistently we have continued to deliver exceptional performance, availability, scalability, and security capabilities for Exadata, Exadata Cloud Service, Exadata Cloud at Customer, and also zero-day loss recovery appliance. We expect to continue to do this with phenomenal price performance advantages. So if you look at from a summary standpoint, number one is Exadata is the world's best database machine. We walked through all the OLTP and analytics workload that it can support, and the mixed workload with even more cost-effective in X9M. We have brought the similar price performance numbers along with cloud control plane and cloud software enhancements for Exadata Cloud at Customer. Many of our leading customers are now transitioning and embracing data modernization using Cloud at Customer, using Exadata Cloud at Customer. And Recovery Appliance complements this entire portfolio by providing an end-to-end, highly scalable data protection and with very effective protection from malware and ransomware. So this technology is phenomenal. This overall portfolio has been phenomenal. The net, what we label as superior architecture, delivers exceptional results.
So, Ashish, last foil already. Time went so fast, you know. We are close to the hour, so that's very nice. Let me see if there are any questions in a moment. I have one question, and we know that an XRCC keeps the data physically in the customer data center, and the question here is on the Oracle Cloud, so the cloud service. The question is, can it be guaranteed that the data will not leave the country border? DSGVO, so data protection law, GDPR. So for a data center, for the XRCC, that's easy. The answer is yes, right?
Yeah, for XRCC, that's easy. And for XRCS, yes, these are given by our terms and conditions. What I meant by XRCS is the Exadata in the public cloud. So for example, if you are choosing to deploy Exadata Cloud Service in the Frankfurt region, it will not leave the Frankfurt region because the data is physically tied to the Exadata system, which is in the Frankfurt region. We don't replicate data to anywhere else. Okay.
Not to Amsterdam or somewhere else. So
it is up to you. For example, if you want to create a data guard standby database, maybe you want to create inside the Frankfurt region or some other OCI region, but that's your choice.
To Singapore, for example. So we have customers that want to work worldwide. So they have US data center and Singapore data center. So that will be supported. But if I want to limit it to Frankfurt, it will just stay in all of the Frankfurt data center, but will not leave Frankfurt.
Right. And by the way, Ralph, and for the rest of your customers, the Frankfurt region is one of our busiest cloud regions. And it keeps growing. So thank you for all the support.
But it's not full, so we still take customers.
Absolutely.
Very good. So I don't see any other question at that point. Ashish, thank you very much for your presentation.
Sure,
thank you, Bojana, thank you in the background for organizing the event and the complete 3 series of that event. Okay, so at last foil, we just have a very short look on the next sessions that coming up. I introduced that at the beginning already. So Oracle Engineering Forum 2021, And please register and enjoy the technical content. So you get a lot of details on our technology there. Ashish, so it was a very, we didn't talk about that. So it's now 6 o'clock in your time, or is it 7 or even worse? Okay. So thank you very much for being that early and take care. So now I switch to German für alle, die in Deutschland. Vielen Dank für die Session, für die ganze Serie. Wir sehen uns beim nächsten Mal wieder. Thank you. Stay healthy and come back when we do the next sessions. Thank you. Goodbye.
Thank you.